Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host for today's episode. This week, Scott Shotton is joining me once again. He's been on the show several times before, national trainer, mobile technician. Scott called me up after my previous episode, and I'll put a link to the show notes in that. But in the second half of last episode, I covered a case study on a 2011 GMC Sierra that was running very, very lean to the point where it couldn't accelerate, it was falling on its face. And I worked through that case study, ultimately determining that the fuel injectors had been swapped out with the incorrect parts from a different 6-liter. The injectors had a different flow rate. So again, if you want to hear the details on that case study, go check out the previous episode. Link is in the show notes. If you've already listened to that and you know the backstory, Scott had called me up and he wanted to point out some things as far as the process of the diagnosis and some ways that we can really utilize fuel trims in making a determination like this, and maybe saving some steps, maybe recognizing problems like this and a couple others utilizing fuel trims. So it's pretty cool stuff. So, I'm always up for pointers if people have suggestions and stuff as far as my process goes. I love to hear it. So this is definitely no exception. But with that out of the way, let's jump right in. All right. Good evening, Scott. How's it going?
I'm fine. How are you?
I'm doing good. Staying very busy. Running around all over the place, doing mobile stuff.
Yep. I'm in the same boat.
Yeah. How was Vision for you? I know we talked a couple times while you were there.
Vision was great. Did you have a good time?
I did. Fantastic. I decided not to record, and I think that was the right decision because I really got to just sit down and enjoy my time, spend some time hanging out with people, and
time to visit, time to see some classes. Yep. No.
Yep.
No. I agree.
Yeah.
And you were in one of my classes, and I forget who said something about you, and I'm like, you realize he's sitting in the class.
Yeah. That wasn't anything too disparaging or anything.
No, it wasn't.
So I wasn't too concerned. But no, Subaru class was fantastic, and I've had
I appreciate it.
Several other people say the same thing since then. So that was definitely a hit.
My biggest complaint about that is Sherry always has me teaching a class when there is another class going on that I would like to see. So I don't get to go see it. That's my biggest complaint. I only taught two classes at Vision this year, and some of the classes I really wanted to see just so happened to be at the same time. But it is what it is. Yeah, that's the tough part about picking classes in general for those, especially something like Vision, is like I want to see 3 of these ones, and they're all going on the same time or the same day. So it's tough to pick. Or I know some people kind of wander from class to class. Guilty.
Yeah, but that, the way I look at it is I try to pick my classes by instructor, that's somebody I know that does their legwork beforehand. They put on a good presentation, and I'm really disappointed when I go about it that way. Even if I miss out on something else, I'm still getting something good here. So
you're disappointed when you go about it, picking by instructor?
No, I'm never disappointed.
Oh, okay. I'm sorry. I thought you said you were disappointed.
No, not at all. No, that's been pretty successful for me. Because sometimes I would try to pick the class just based on the title or the subject matter, and then it's just sort of, you never really know what you're going to get. You might get a fantastic class. You might get one that's not so great, but going to enough events and training online and things like that, you start to learn, okay, these are the guys or gals or whoever that really put on a good class. And I try to follow that. Of course, you know, there's always going to be new people up and coming, but,
Right. You and I are both instructors, so we may have a little bit different perspective sometimes when we go to a class, and we're not only paying attention to content, we're paying attention to, you know, what the instructor's doing, their mannerisms, their, you know, what can I take from this as an instructor and so forth. So I completely agree with you. I pick most of my classes when I'm attending based on the instructors and accessibility to those instructors. But occasionally I will, you know, pick a new instructor. I'm like, all right, I'm going to go here and see, because
they got.
You never know. That might be the up and coming rock star, you know, or it might be a, you know, you know,
need a little more practice.
Until you check.
Right. But you know, just good to be back in person, live training again.
Oh yeah.
That's been fantastic. So I think my next one I'm going to try to hit up is if they do Super Saturday. I'm going to try to go to that one because I've never been, and I hear really great things about it, but it's been canceled the last 2 years. So
yeah, I was supposed to be there, but it got canceled. So I have never been there either.
Okay.
I'm hoping to be there. Hopefully it runs this year.
Yeah.
You know, and then you've been to ASTE, right? Yep. I haven't been there yet, and hopefully next year I'll be there. I'm talking to Lucas about that, so we'll see.
Cool.
We'll see.
Did I heard your podcast with the two of them about doing some in-shop training?
Yeah. Sorry, I had to laugh.
Well, yeah.
David totally. If I go back and listen to that podcast, David totally derailed me so many times. I'm like, I've said the same thing over and over and over again. It's because it is ADD. And if Lucas is listening to this podcast, hey Lucas, if he's listening to the podcast, he's going to laugh, because if you listen to that closely, you can hear Lucas laughing in the background when I'm. Okay, we'll leave it at that.
I was going to ask though, have you progressed with that or done that for any shops yet where you've gone in and done
I've been doing a little bit here and there. Actually, next week I'm heading to a shop in Wisconsin, which I have done 2 or 3 visits for. Heading up there for another visit. It's pretty small, you know, and again, there's a cost factor, and you know, if the shop isn't investing in a business coach, they're not going to invest in a training coach.
Sure.
Right?
Sure.
You know, but I mean, it's available if you want it. And, you know, I think the shops that are doing it keep coming back and doing it, but you know, there's only a handful, you know.
Yeah.
Well, we'll see.
Well,
and again, I'm not a salesman either. So the podcast where it comes up, I'm not like, hey, call me. No, nope. No,
well,
here's what we have to offer. If you want it, give me a call. If not, whatever.
I think there's some potential to that for sure. I know I've had a few shops ask, you know, because I go around do the mobile thing, like, hey, do you do any electrical training for my guys? And I've been too busy to even consider something like that. But you know, like you say, for the right shop and the people that are interested in it, there's a market for it. But yeah, you would have to. I think you'd really have to go out and seek that and you know, start.
You know, if you're talking a local shop, like one of your regulars,
yeah,
that's a little bit different than, you know, traveling around the country and training. And I've done a couple, 3 or 4 trainings here or there for some of the local shops I deal with. They're like, can you come in and tell us about this? And there's only 3 guys and we're sitting in their shop. I'm like, okay, well, you know what? You're 15 minutes from my house. We're just going to chill out for an afternoon, evening, and talk. All right, I'll just bill you my normal mobile rate, you know, $150 an hour, whatever it is. I just threw a number out, right? $150 an hour. We're there for 3 hours. You make, you know, $450. and you sit there and do what you got to do with a laptop or, hook up to a car or whatever the case. As soon as you start getting in bigger groups or you have to start traveling and having 4-hour classes, that's when it completely changes. But for someone local, I do not mind, especially if they're a receptive shop. I do not mind going, all right, cool, I'll spend a couple hours. Right?
Yeah. So yeah, maybe this summer when I got some more time, I might look into putting together something like that. And
you college instructor, summertime's off, right?
That's right. Yeah, I'm at that point of the year now where we got about a month left, and I am ready to be done with that. It's as you know, so it gets to be a long year.
Yeah, I know.
I
know, but you also get spoiled because I was there. You also get spoiled. Hey, summer's off.
Mm-hmm.
Well, it's not summer's off if you do what we do.
Right. I've managed to get 2 full-time jobs for myself pretty much. So not really a summer off, just a shift in priorities and responsibilities and workload. So yeah.
The hardest part is when you're a full-time college instructor during the 2 semesters of the year is turning shops down during those 2 semesters. That's my experience that was the hardest part. Oh yeah, I can't be there today. Mm-hmm. I can be there 2 days from now.
Yeah.
That was the hardest part.
Yep. Well, cause I could take 2, maybe 3 jobs on in an afternoon after class. And that's 3's pushing it because if one goes wrong, then the afternoon's ruined, which easily can happen. And so then that fills up pretty quickly, at least for me now. I'll get 2 days filled up. So then they call me. I'm like, 2-3 days from now in the afternoon. So I won't be there till Thursday at 2:00. And they're like, what? So
I hate when they ask the time. What time are you going to be here? Sometime in the afternoon. Sometime mid-morning. Yeah. What are you going to do?
Yep. But I did find the shops that, put up have a fit about it and whatever. They're probably not the ones that I really want to be working with anyways, that need it like right now. It's got to be done right now. I don't really prefer those. I like the ones that they get the car and just say, okay, well, when you get here, you get here. We'll deal with it then. You know
what some of those don't understand is the customer wants it done right now, but it's been at their shop for a week or 2. And now that you're on the phone, they're passing the buck and going, I want it now. Well, wait, this has been at your shop for 2 weeks. So you can wait a day.
Exactly.
Right? We got to fix it. We'll fix it, but you got to wait a day. So, I'm sorry. We kind of went on a completely different rant, but that's okay.
Yeah, that tends to happen. I have no problems with that. But so the reason I've got you on this evening is you gave me a jingle after I put out the last episode talking about a GMC Sierra with some fuel injector problems.
Yeah.
And you had some suggestions and some ideas about it. So I am all ears because I always want to know what I'm doing. Can it be more efficient, more accurate? I do. It's weird because I do have pride in what I do. I think you have to, but I'm always looking for outside input to like, okay, well, how could I be better at what I'm doing? So I love hearing it from people if they've got suggestions, and I'm definitely excited to hear yours.
Well, first of all, you knocked it out of the park. You got the car done, right? You figured it out.
Yes.
Perfect. Second of all, kudos to your student who you didn't name, but had mentioned, hey, should we see if anything else was done to this vehicle? Right?
Yep.
And you said it in the podcast. Kudos to that student. I hope that student's doing well. And I'm looking forward to seeing him. I believe it's a him in the industry. Right?
Yep.
Okay. Yep. I would have said her, but I believe in your podcast you said he. So
yeah, I do have a female student this year who's doing very well. But the student that was with me, his name's Mike, and he is he's going to do very well in this field.
Good.
For
Hey,
sure.
Mike, keep with it.
Mm-hmm.
Right? Hopefully he listens to this. If not, you need to make him listen to homework.
Yeah, I'll send him a link for sure.
Anyway, you did everything exactly the way I would have. And I'm a very process-oriented person. And I don't want this to be like a mini class, but you went into that vehicle and discovered the O2s had an issue, correct?
Yes, that was the first trip there.
Right. And anyone listening, go back to the previous episode to listen to see what we're talking about, right? Okay. So you got to get the O2s fixed before you use fuel trims.
Yep.
Agreed? Because fuel trims are based on O2 sensors. So we'll leave that whole first half of the story for someone that wants to listen to the previous episode. You got the O2s fixed. Now we can trust fuel trims. Agreed?
Agreed.
Okay.
Before we jump onto that, and maybe this will derail us, so you can call me David, but I was thinking about this because I always think about it, after I put out the episode, I'm thinking about the car. So those front O2s were worthless. They didn't work, but the rears did seem to be working. They did seem to be responding correctly. Do you think, and you could just leave it with a yes or no, I don't think this would have worked. We don't have to go into it too deeply, but do you think had I jumped the signal wire for the rears into the fronts, just unplug the front O2s and jump the signal wire from the rears into the fronts, I might have been able to utilize some fuel trims to get an idea where I was headed?
Okay. That's an interesting thought. Now,
I've never tried it, so I don't know.
We're theorizing right now. If I'm not mistaken, this vehicle had no cats in it.
They had just been replaced.
Oh, so they did put cats in it.
Yeah, okay. The cats got cut out, which is why they put on a Y pipe and the new O2s.
See, if the cats were cut out and someone put in straight pipes, I think you'd be perfectly fine using the downstreams.
But with the cats there.
Especially new cats.
Yeah.
That's a judgment call. That's something we would have to... Damn it, Sean! You're giving more homework to do.
I like to do this. No. I do this to Fanslow all the time.
I know, and you know what? If you know what, I'm going to sit down and eat something and go to sleep, and then think about this. Fanslow would be up till like 2:00 in the morning researching.
Yeah.
Anyway.
Okay. Yeah. Anyways,
I lost where we're at.
Okay, so we determined that the front O2s were non-functional.
Okay, all right.
Those need to be replaced before we can proceed.
Cool. So we got the O2s in, okay, and then you did the exact same thing I would do. Again, I'm going through my procedure. I do it the same every time. If we got lean codes, rich codes, low power, things that drivability issues, right? You're most likely plugging a scan tool in first, pulling codes, and then going for a test drive and looking at fuel trims, provided we know the O2s are working, right? Yep. Okay. And you know that, and for the sake of your listeners, okay, if we have a vacuum leak, okay, at idle on a mass airflow sensor vehicle, at idle with the throttle plate closed, our fuel trims are going to be what? Negative or positive?
Positive.
Positive, right? Because we got some unmetered air coming in. We're under-injecting fuel, however you want to look at it, right? But then once you start to open the throttle, now the percentage of air that's sneaking in, if anything, through that vacuum leak is insignificant, so our fuel trims get better, correct?
Yep.
Right?
Yep.
So, I mean, I'm one of those guys that I look at scan data and sitting in the bay, going, all right, I got positive fuel trims at idle. Let's bring the RPMs up and see if the fuel trims get better. And if they do, I'm leaning towards a vacuum leak, right? If I've got a low power complaint and the fuel trims are okay or maybe a little bit positive at idle, but I bring RPM up or I brake torque it and the fuel trims get worse, now we're looking at maybe a fuel delivery issue, okay, or maybe a mass airflow issue, or air metering issue, be the best way to say it, right? But that's where the VE test drive comes in. So you go do the VE test drive, which you definitely covered in your last podcast, right?
Mhm.
So looking at that vehicle, I mean, we're just looking at pieces of data. Looking at the vehicle that you had, okay, that GM truck with the 6-liter.
Yep.
VE was good. Means the engine can breathe. O2s went lean. Fuel trim was positive. After we fixed the O2s.
Correct. Yeah.
Correct?
Yep.
Okay. So that automatically to me means a fuel delivery issue, right? Next thing is how's the fuel pump? But you covered that, right? You said you had a fuel pressure gauge, and I rarely connect a fuel pressure gauge anymore, but connected the fuel pressure gauge, and we had good pressure. We also talked about, or you talked about fuel volume, right? And I'm sure you've done it, and I've done it too. Take that fuel pressure gauge and tape it to the windshield and go hammer on it driving down the road.
Exactly.
Right? And if you have, I think you said 60 or 65 PSI in the podcast.
Yeah, it's close to 60.
If you have that under load, you have volume because volume maintains pressure. So you're good. Nothing against a fuel volume test, but I'm not going to do the test if I don't have to.
Right.
Right. So we're looking at a lean condition with good volumetric efficiency, meaning the engine can breathe, but we do have a fuel issue. That's where you were at, right? Okay. Now, what made me think about calling you was how can you see those fuel injectors in fuel trim?
That's a good question.
Okay. Think about it this way. Those fuel, I don't have the numbers written down, but they had a different flow rate, correct?
Yep. It was 30 pounds and 44 pounds per hour.
Okay. So at idle, they will flow a specific percentage less, correct? At 2,000 RPMs, they're going to flow the same percentage less, correct?
Sure.
At 4,000 RPMs, at under load, because their flow rate is different, they're going to flow the same percentage less. So one of the things I look for, and we're going to expand on this in a minute, because it's not just fuel injectors that can do this. But if you and I, and hopefully your listeners are comfortable with a plus or minus 5%, maybe 10% fuel trim number,
Sure.
right?
Pretty normal.
Okay? Short term plus long term, total trim, it fits in that plus or minus 5 window, which is a 10% window. Okay. If we have fuel injectors that don't flow the right amount, let's say they flow less, which is what you had happen, right? If you were to look at those fuel trim numbers, and I'm doing this, the audience can't see it because I'm doing it visually, but you can, right? Skew that whole thing high. Right. So if we have, plus 25, plus 27, plus 29, plus 27, plus under all different driving conditions in closed loop, they're all still in that. They're all still positive, but they're all still in that 10% window. Right. So everything's working fine, except that the injectors, it could be the injectors, but in this case, it's the injectors. Right? It could go the other way around too. So if you had injectors with a higher flow rate installed, then it would be the opposite. It would be negative. But provided everything else is working correctly on the car, it's not like the vacuum leak that I brought up. Okay, we got high positive trims at idle because we have the wrong fuel injectors. When I bring it up on the higher RPMs, it's not going to get better. If it's a vacuum leak, it will. Right. But if it's the injectors, it's not. So does that make sense? It's math is really what it is.
Yeah. So let me make sure that I understand this correctly. So what you're saying is the percentage of correction will remain the same throughout different load ranges if the issue is a injector that's not moving enough fuel or too much fuel.
If all the injectors are wrong.
Yes. Okay.
See, we got to be careful there. If someone put one wrong injector in, then we're probably chasing a misfire or something like that. Right. But in your case, they put a set of injectors in.
Yep. All 8. So.
Right. Okay. And And you know what? This is a man-made issue. Agreed?
Oh, for sure. Yeah.
And,
yeah,
and
definitely.
the reason I know this is because I've seen it multiple times, and it's always a man-made issue. It's a Ford Taurus that had a one model year newer junkyard engine installed, and they left the original injectors in it, but it had a different fuel system in it, and the flow rate was slightly different. I had a 2005 Mazda 3 with a 2-liter that had 28%. I wrote it down before our phone call. 28% positive trims, and it had an engine that grenaded, and a shop put one junkyard engine in it, and it was locked up. Don't ask me why they didn't try and spin the engine over by hand first. So they put a second engine in it, and now it starts and runs, and it's setting lean codes. Okay, and I think it was lean. Yeah, it was lean codes. And I'm in Chicago, and when I went out to look at this vehicle, well, first of all, I talked to the shop. It was a good customer of mine, and I said, check it for ethanol. There's something going on with ethanol because of what I just told you. The fuel trims were positive under all conditions, right? At idle, driving down the road, under load. You know, as long as it's a closed loop, they were all, I'm like, check it for ethanol. So they did an ethanol test, and it passed for ethanol. I'm like, okay, I'll come out and take a look. So I went out and took a look, and when I plugged it in the IDS, the Mazda, it pulled up as a California emissions vehicle. And I luckily caught that. I'm in Chicago. What's the chance of getting a California emissions engine from a junkyard in Chicago?
Right.
So we did a little research, and I have the numbers written down for you. The California injectors are 260 to 320 milliliters per minute. The federal are 195 to 245 milliliters per minute. And if you do the math, that's roughly 75% of the fuel flow. And our trims were 28%. So 75 and 28, that's pretty damn close to 100.
Okay.
Right? So I mean, it was a fuel. It was the same issue you ran into. Same exact thing.
Okay.
Right. But the point is what I really wanted to point out was you're used to looking at trims under different conditions. If they are the same positive or the same negative under all conditions, injectors could be one.
I was going to ask what else could cause that same.
See, that's where we're going. Okay. Now, this is something that some people don't like to talk about. And I'll ask it in class. Like, do you guys have E85 in your area?
Oh, yeah.
Yeah, you do. Yep. Okay. There's people that'll say, nope, don't have it. Don't have to worry about it. Let me ask you this question. Do you have to worry about it?
Well, yeah.
Right? Well, I mean, think about it. The highways, even if you're in a town that doesn't have E85 at the pumps, right? And your regular customer that lives out in the sticks with you goes out on a trip, and they happen to accidentally fill a tank with E85, and then they get back home and their car's not running right. Or you live close to the highway where they have E85 pumps.
Yep.
Right? Doesn't mean you have to have them in your town, but you have to understand there is a possibility that you're going to have E85.
Yeah.
In a tank.
And this might not be the direction we're going to go with this, but I have found it so important to get a fuel sample no matter what. If you're going down this path with, whether it be fuel trim issues or even starting issues, and just take a sample of that fuel. It's so easy to do, and it's so overlooked by a lot of technicians and shops. It's just to use a plastic water bottle and just take a look at it. And you can do the water mix thing, and you might talk about that, but just to get a visual of the gas has solved a lot of vehicles for me.
Yeah, I mean, you are right, and that is the point. And when a technician first runs into this and it bites them in the ass, and they're going to realize how simple it is. But ethanol does the same exact thing as injectors with the wrong flow rate.
Okay.
And the reason is the air-fuel ratio is different. So, for example, if we took a, 1998 4.3 liter Chevy T10 Blazer.
Sure.
Right?
Very popular back in the day.
We put ethanol back in the tank, right? E85, whatever the case. It'll still run. Some cars won't run. Corollas, by the way, won't run with too much ethanol, but I know that from experience too. But the point is that the air-fuel ratio is different. So you're going to set lean codes, PO171, PO174, right? You might have low power complaints, depending on how much ethanol is in the tank, on hard acceleration. But if it goes into closed loop and you're not hard accelerating, it's going to compensate. So you're going to see positive fuel trim numbers, but your fuel trim numbers are going to be the same or close to the same across the board. At idle, they're going to be plus 27. I'm just picking numbers. It depends on how much ethanol is in there. This be plus 27. When you're cruising down the road under light load at 2,500 RPMs, it might be plus 26, it might be plus 25, but it's still across the operating range. It's all still in that plus or minus 5 window, 10% window. It's just skewed high, right? Yeah. So that is the giveaway. VE is going to be good, because the engine can still breathe. We're probably going to have lean codes. We might have low power complaints. O2s work. We confirm that. And then our trims are skewed this direction, skewed high. Total good indicator.
Let me ask you this. And actually, first, I'm going to say that Blazer that has E85 is also going to need a pulsator in the fuel tank and a regulator.
Yeah, very possibly. Right?
But I did a lot of GM fuel pumps for the ethanol content back in the day. But so let's say a mass airflow sensor was skewed in the lean direction, right? It's dirty, or it's just skewed and it's adding trim. Would that give us the same effect with the fuel trims being off the same amount across the board?
From my experience, no. What it does is it could be near normal at idle, maybe, but the higher the RPM or the higher the engine load, the worse it gets. Okay. And if you do the VE test drive, which you did on yours, which is part of my diagnostics too, I'm already driving it around to see what the fuel trims are under all different conditions. One piece of that test drive is flooring it and doing the VE test drive, and that mass airflow sensor is going to make that VE number horrible. Yeah. So we have lean O2s, poor VE, automatically going towards air metering. I don't want to say mass airflow. It could be a cut in the tube or something, but whatever the case, right? But ethanol or wrong fuel injectors, we're going to have good VE, and or potentially rich if you had injectors with a smaller flow rate. If they were the other way around, it would have been rich, but the fuel trim numbers would have done the same thing. It would have been negative numbers, but equal across the board. But our VE numbers would have been good. Yeah, right? We can rule out the mass airflow sensor. Just go punch it and do a VE calculation. If our VE is good, you don't have a mass airflow sensor issue.
Yeah, I don't recall the exact class I was in where that was explained to me, that the VE test, because I had heard of it before and I thought it was just for engine breathing, and I didn't use it that much. I'd run into a restricted cat here and there, and I could usually pick that out pretty easily. But then somebody explained, well, you can use this to assess the mass airflow sensor's accuracy. And then it's very simple, because it's using that as part of the calculation. If that's off, the calculation's off. And then I did a few of them. I had a mass airflow on a Hyundai that was running very rich, and I went out and did the VE test. And this is like a 2003 Santa Fe that's got 200,000 miles on it. And it comes back at like 115% efficiency in the VE. I'm like, okay, all right. I know where my problem is now. This mass airflow sensor is over reporting quite a bit, but That was definitely eye-opening when I was explained
And that's an
how
odd
you can
one.
use that. Yeah.
That's an odd one. They don't usually over-report.
No, I don't see that too often. It's usually the opposite direction.
Right. But and you said, the VE test is only a measure of engine breathing. Well, it is a measure of engine breathing with the addition of we can cross-check the mass airflow sensor, right?
That's where I use it most.
Right. But it also lets us rule different things out. I treat it almost as another data PID. Right? Okay, my VE is good. Okay, I don't have a breathing problem. Oh, you know what? There's even another one. Fords. What altitude? You're probably at a similar altitude to me.
Yeah.
I'm about 640 feet above sea level.
Yeah, I'm pretty close to that. I know the Barrow's 14.3 here.
Okay.
And I know the Ford is 152 hertz is pretty close to normal for me.
Okay, so that's a little bit. I'm more like 156 hertz. Okay. And that's what I was going to bring up is whenever, because of how Ford does it, they calculate barometric pressure based on the mass airflow sensor input. So if we have a air restriction, an exhaust restriction, or a bad mass airflow sensor, anything that messes with engine breathing, you're going to have a bad baro reading. Yep. You're going to. So when I wish every manufacturer did that way, because as soon as I plug into a Ford, I pull up baro in my PID list. And like, what do you need to do baro for or whatever? I'm like, because if this baro says 132 hertz, I know damn well I do a VE test drive, we're going to have a bad number. Yep. Right? That's all I know. I don't know if it's a bad mass airflow. I don't know if it's a plug cat. I don't know if it's a plastic bag got sucked into the air filter. Doesn't matter. All I know is there is either an engine breathing or an engine breathing calculation problem. Either way, it's a quick way to check. It's just a data PID to look at.
I was trying to explain to my students how Ford does their baro calculation with using the mass airflow sensor, and they do it at a wide open scenario. And the students were looking at me like I was speaking a different language. They're like, well, why don't they just use a pressure sensor? I'm like, I don't know. That's the way that they chose to go. It does seem complex, but that's their method. But if you understand it, you can use it. What was the other? I had another line of thought there, and I think I just lost it. But
all right, I was going to pause for a minute and let you think. I see the wheels turning.
Yeah, the wheels are turning. Oh, because you mentioned that you use it as a data PID, right? The VE. Are there any data PIDs on vehicles that you'll substitute in for a VE test? Because there's some options out there.
No, there's different load PIDs. Okay, there's calculated load, there's absolute load, and there's another one, and it's a required PID by SAE standards since 1996. And sometimes it's accurate, sometimes it's not. If you don't understand it, and I still do this to this day, I will look at the load PID on the scan tool, but I will still do the VE calculation. Okay. And once I do the VE calculation and then I compare it to the load PIDs, all right, okay, cool. Absolute load and calculated load. Okay, calculated load is exactly what I came up with the VE calculator, and absolute load is, it's a turbocharged car or something. That even adds extra things into the mix. I always do the VE calculation the first time around and then compare it to the data. If the load PID that I'm looking at matches my VE number really close, and then I fix the car and I go do the repair verification test drive, I may or may not do the VE calculation afterwards, because now I trust the load PID because I know what it's doing. Think about it. You talked about it in your last podcast. It's the displacement of the engine, the RPM it's spinning at, how much air should it flow compared to how much air it's flowing. I mean, there's very little variables there.
Right.
Either it's right or it's not. But a load PID, who knows what's programmed inside that PCM, that ECM, that DME,
Right.
How are they calculating it? I don't know. So I always tend to do the VE calculation first, and then look at my data pits, and then decide what to do. And anyway.
All right. On the ethanol thing, I'm sure I've explained it on the podcast before, but it's a very simple check that a lot of people have done to put some water into some sort of container. And there's videos out there. You can do it with a graduated cylinder and really dial it in and do 10 milliliters of water. And then what's the number of gas that you put in there?
I do it a little bit different. I do it really simple.
Yeah.
100 milliliter graduated cylinder.
Okay.
100 milliliters. Nice, simple math. 50 milliliters of fuel sample, 50 milliliters of water. Half
and half. Okay.
Yep.
Okay.
Shake it up. And then for every milliliter that dividing line rises, you're about 2% ethanol.
Gotcha. Okay. Okay.
So, if it goes up 10 milliliters, you're 20% ethanol. And no, granted, it's not like super scientific grade, whatever, but does it really matter?
If you're looking for E85, then no.
Okay, so let's go to the next vehicle. Okay, the next case. We already did your vehicle with the wrong fuel injectors.
Yep.
And I brought up the Mazda, which I've also seen on Fords, and you obviously saw on GMs. So again, man-made issue, wrong injectors. Okay. Mm-hmm. Then we talked about ethanol being in the fuel tank of a non-flex fuel car, where our fuel trims go positive, but they're the same positive across the board.
Mm-hmm.
Right?
Yep.
Okay. Now, okay. A vehicle presents itself. Let's say a later model 5-liter F-150 has PO 172, PO 175 rich codes. Mm-hmm. So if you have ethanol in the tank, you'd be running lean, right?
Correct.
But this vehicle is a flex fuel vehicle. So whenever I get a vehicle nowadays that has rich codes, the first thing I do is I go and pull up the scan data and find out, is it flex fuel and what is the ethanol percentage? Because many of these vehicles nowadays it's inferred. There's not an ethanol sensor like the old 4-cylinder S10 pickups in the early 90s or mid 90s, right? They're inferred, right? And I've seen many of them learn the wrong ethanol content. So if they learn 76% seems to be a really common number. I don't know why, but 76% ethanol, it thinks there's ethanol, so it's injecting more fuel based on its programming. The O2C, it's running rich. It cuts back. We set our rich codes, but it's going to be the same thing fuel trim-wise. It's going to be the same at idle. It's going to be the same at mid-throttle. It's going to be the same driving around the road. So we're going to still have that whole plus or minus 10% window, but in this case, it's going to be shifted negative because we're taking fuel away, right? And sometimes it's just a matter of going in and take a fuel sample if you want to and test it. But how many people are putting the 85 in their cars? They have flex fuel cars. They're just putting gas in it.
Right.
For the most part, right? Mm-hmm. So if you have an F-150, or I've seen it on GM trucks, right? They're setting rich codes. They have learned an ethanol value that's incorrect. You clear the ethanol value. Fuel trims are perfect. Take a sample if you want and make sure. Now, Ford's not so easy. Ford doesn't have a scan tool button that lets you clear the code. Or, I'm sorry, clear the ethanol content like GM does. But
yeah, I've done the GMs. I can't think of a Ford that I've reset. Is that just like do you reset the cam? Will that do it in the PCM? No?
Nope.
Okay.
Nope. You can try and do a capacitive discharge if you want to call it that. Yeah. You can do all that stuff. Doesn't work. Doesn't do it. So
really?
Basically, the last one I did, I kind of want to mess with the people I was dealing with. So I said, here's what you got to do. You got to drain the fuel out of the tank, turn the key on, start the car, shut it back off, fill the tank back up so it sees a 6-gallon increase, fill the tank back up, and then start it, and then it will relearn and drive it around. And they did that. Now, we're mobile guys. How are you going to get around that?
Well, we'll do some circuit modification to the fuel level sensor. Yeah.
A resistor, right? You're going to do a key cycle. Because what it wants to see is it wants to see you shut the car off with 2 gallons in the tank. And the next time you start it, it's got 20 gallons in the tank. Then it knows you added fuel. Then it goes into its learned procedure. Right? So if you lie to it, instead of, draining the fuel tank out, could we pull the connector, put in the right resistor that says, it's a quarter tank of gas. Turn the key on. Turn the key off, plug it back in. It says 3/4 of a tank. Start it, drive it, relearn. Yeah.
Okay.
But you won't find that in service information.
I was just going to ask that is the method of learning in service information for Fords?
I believe it tells you the criteria.
Okay.
Right.
Okay.
It might say something along the lines of, it needs to see a key off cycle, a 6-gallon fuel increase at the next key on cycle, at which point it will, do the relearn. I'm assuming that means that, the O2s and stuff were working fine before you shut the key off, because it's basing it on fuel trims. It's really what it's doing.
Sure. Yeah. I'd read that in GM vehicles, the description operation on how it's even coming to that conclusion. And I know on some of the older, I think it was like Impalas and things like that in the earlier 2000s, there was even a reflash for it. They updated the PCM software because they were going out of whack so often and they'd be skewed. But you could go in, you could look at that percentage, test the fuel, question the customer. It was pretty easy to come to a conclusion there. I had a string of vehicles with E85 in the tank, at a few different places, some different car lots that I do work for, and they were all getting the cars from the same auction place. And for whatever reason, however it happened, they were putting E85 in all of the vehicles that got sold at the auction.
It's cheaper, it'll work.
Exactly. And so it was about a month, and I was just one after another. And so I just got to the point where I just was checking the fuel sample immediately and had my answer. But it's okay, let me ask you this. Just recently, I think it was yesterday or day before, the government announced that they're going to be not banning E20 during the summertime. That would normally happen June through September. I think it was that they're going to allow the sale of E20. Have you seen anything with like an E15 and E20 cause any issues in cars?
I don't think so. I mean, half the cars that are on the road now are capable of dealing with that. Right. Everything here in Minnesota is E10 at the minimum. So yeah, and have you ever tested from the fuel pump? Have you ever done that? I've done that too because I'm a nerd like that.
To actually see what the content
fuel samples
is.
And done ethanol tests.
Yeah, we do them in class at school.
Yeah, and so it says up to in Illinois it says like up to 10%, unless the pump says E15 or something like that. But the other ones say up to 10% ethanol. But every sample we took was 3, 4, 5%. It was never 10%.
Yeah, it definitely depends on the time of year, the gas station, all of that stuff. There's non-oxygenated gas here too. I don't know if that's sold in every state or not. So you can get some that has no ethanol and people like that for their boats and lawnmowers and
I've seen that. Like not where I'm at, but I've seen that, especially near like lakes and things where people do boats and fishing, and
there's a few of those
all over that. But yeah, but you know what? I mean, you asked the question about in modern vehicles. I mean, I drive a 14, so it's not new. A 14 Silverado, but it's flex fuel. And I never put E85 in it. But if I got E15 or E20, I probably wouldn't even notice.
Right.
it would probably compensate. You know, I kind of want to intentionally put some ethanol in it and plug a scan tool in and do some recordings to see what happens. But I kind of need my truck to work. So I don't want to screw it up, right?
Right. Right. No, then it drops your mileage just a little bit. So
Yeah.
I know there's debate on the.
There was a time when, this was a handful of years ago, I was teaching for the Illinois EPA. And the two guys that work for the EPA came and picked me up here. I'm in northern Illinois, and we drove down together in a GM sedan, a Malibu, something of that nature. Okay, we drove from here to East St. Louis, and because it was a flex fuel vehicle, the state required that they put E85 in it. So we found a gas station close to us, and we got E85, and we did the math while we were driving and figuring it out. And we compared the mileage, fuel mileage, to the dollar mileage. Because the E85 was cheaper, and it worked out to be about the same. At that time, anyway, was almost exactly the same. So we drove, 5 hours or 4 hours to St. Louis and 4 hours back, and everything worked out. If you were counting your wallet mileage, it was exactly the same. Cheaper to fill up. You just have to stop more often.
Yeah, stop more often. That's the thing. And then all the race guys love to use that E85 because you can bump up that ignition timing too.
Yeah. There's some chemistry things going on there too.
Yep. I've had a number of students that want to do the E85 conversion to their BMW or whatever they're messing around with, so they can change the timing to crazy
you know
levels.
what there's one way I took out of that, especially when I was a college instructor, and I had the younger, it was usually guys, so I'm just gonna say guys in general, right? The younger guys, they're like, oh, I want to do this. I'm like, learn how it works first before you try and modify it. So you got a question about how it works factory-wise, call me all day long. You're going to bolt a turbocharger onto that? Nope. I don't want anything to do with it. Can you find me a factory wiring diagram for that remote start? Nope. Okay, then I don't want to deal with it.
Yeah.
I got one more thing here, and I think we talked about this beforehand because we were talking about fuel trims being skewed one way or the other.
Yep.
Incorrect injector flow rate, incorrect ethanol content, okay? Non-flex fuel vehicle with ethanol in the tank, positive fuel trim numbers. Flex fuel vehicle, incorrectly learned positive ethanol content, negative fuel trim numbers. This is one, and again, I told you on the phone, or on this call before we started recording, I've run into this twice the past month. This is a GM. I'm going to read this TSB, or I'm going to summarize this TSB. It's a 2010 Malibu with a 2.4. Okay, and apparently around this time frame there were two RPO codes, so an LE5 and an LE9. Okay, twice I have been called on these vehicles for setting PO172 rich code, which would lead me to look at ethanol content. But the vehicle is, quote unquote, not a flex fuel vehicle. So if you go in with a scan tool, you don't get an ethanol PID, you don't get an option to reset ethanol or whatever the case. Okay? Well, apparently, these vehicles, Malibu and Pontiac G6, they have ethanol software in the module, and you can't see it in the scan tool. So let me read this real quick, because a TSB solved this issue for me. Actually, the fuel trims led me to, this has the wrong ethanol content, but it's not a flex fuel vehicle. Does that make sense?
Yep.
Right, so the fuel trims took me this way. I'm like, no, dude, you did everything. This shop did everything they needed to do. I looked at the trim numbers. They're the same across the board. They're just skewed. I'm like, this is freaking ethanol, but it's rich, not lean. So this is a non-flex fuel vehicle that has learned ethanol. I'm like, what the hell? So again, don't hesitate to look at TSBs. basically what it says, just for your listening audience, right, for their pleasure, okay, build the vehicle with an LE9 engine, even if it has an LE5 engine, because they are both 2.4 liters. They're both 2.4 liters. One is a VIN B and one is a VIN 0. Okay. If you build it, and I know because I've done this twice, if you build it as an LE9, it will give you the option to view the ethanol content, and it will be wrong, and it will give you the option to clear it and solve the issue. But again, fuel trims led me to, it's not software programming. It's just, you got to lie to the car.
The scan tool won't show you what's actually there.
Right, because it thinks it's a non-flex fuel vehicle. And technically it's not sold as a flex fuel vehicle, but apparently it incorrectly can learn the ethanol content. And
yeah, that's interesting. I know across the years I've solved various issues or completed certain tasks by changing that year or engine or something in the scan tool, or even in service information. Just let's go up 1 year, down 1 year and try this. And then it magically works. And it's always just, you wasted so much time. You're like, really, that's all I had to do is change that one.
It's always a gamble. It's always a gamble because, especially if you're lying to a scan tool, right? You may get the right data. You might not. Right. But you have to accept the fact that I lied to the scan tool. Okay, if it's not right, good. Okay, as far as service information, sometimes I do agree with that totally. Like wire colors don't match. You go 1 year newer or 1 year older, and okay, now the wire colors match. All right, cool. We're in the right place. Mid-production year stuff and.
Yep. Yeah, we do that. We do a lot of that work with the students. Is your ability to search service information is going to be one of your most important skills. Obviously you want to be able to fix the car, figure out the car, but your ability to find the information within whatever system you're using, that should not be overlooked. And you should practice that as a skill because it's tough sometimes. You got to know those little tricks. You got to
Do you guys have all data and pro demand?
We have those two and Identifix. So we're lucky to give them access and ability for all three because we want them to be able to use whatever they have going out into a shop.
Okay. And shortly before I left the college, I got tasked with putting together an introductory class. And we spent a bunch of time talking about service information, interviewing process, certifications, all the basic stuff to get you going. And one of the things we talked about was service information. And I don't know if you know it or not, but it's something you could use with your students. Is all data has a test. Have you done that?
I haven't. No.
Okay, it's like a certification test. It's nothing crazy. But basically, it forces them to go through and look up stuff and answer questions. Now, if I wrote a test that said, hey, what's the firing order of a small block Chevy, a 1998 5.7 liter, right? Sure. You know what they're going to do? They're going to Google it.
Yep.
They're not going to look at the service information. But the all data test forces them to use all data to answer the questions.
Gotcha.
ProDemand also has one, and I believe you might have to email them to get your students access to that. You guys already have an account, so get access to that. And basically, then they get 2 little mini certifications. So it's a little pat on the back, something for their resume, but it also it forces them to look up the information in all data or ProDemand or whatever the case. So I mean, I made them do the tests.
Yeah. We do so much stuff with them where it's forcing them to find a piece of information. And I do it a lot where we'll be talking about something. We're doing airbags right now. And so I'll say, okay, we're going on break, but hit up the computer lab, use your vehicle you drove here and find where this component's located or find this reset procedure and take a picture, print it off, whatever, and we'll talk about it when we get back. And just simple stuff like that. I just want them to get into the flow of being able to navigate the systems to know where to find this stuff, because you know as well as I do, sometimes the search bar on top doesn't get you what you need. It's very helpful in a lot of cases, but the ability to actually know where things are, you know, in the organization of the service info is huge, absolutely huge.
Right. Right. And that's why I made the students do both all data and pro demand, because who knows which one they're going to have when they get hired at a shop.
Exactly.
Because most shops don't have both. Well, hopefully they have at least one, right?
Yeah.
Hopefully.
Yeah. Right. Right.
Right.
No.
But yeah. Oh, speaking of airbags.
Yes.
Do you blow them up in class?
Yeah, that's Tuesday. Next Tuesday, actually, we're going to be setting off one of those in a pre-tensioner. So,
all right. I think I remember one of your previous podcasts, and there may actually be a YouTube video of me setting off some airbags, but we'll leave that off to the side. You're not supposed to measure the resistance of an airbag, right?
Yeah, they say don't do it with an ohm meter. We try every year, though.
I was going to say we would pull out every ohm meter we could find. Right, every single one, even the old needle style snap-on or whatever, and we would take another voltmeter and we would measure the voltage of what every meter put out, and then we'd lay them on order, and we put the lowest voltage first to the highest voltage, and then we would take a seatbelt pretensioner and stretch the seatbelt out. We'd cut it so there was no buckle, and some student that had enough nuts would wear a welding glove. I wouldn't let them wrap it around their hand. I said, you've got to hold on to the strap, right? And stand back, so they're 15 feet away. And that would be in a vise. And we'd stretch some jumper wires out and go, all right, let's try measuring the resistance with this meter. And every time they would like twitch. Like it was going to go off. Nope, that didn't do it. Next one. Nope, that would do it. And every meter we ever tried wouldn't do it. And then I would jumper power and ground to it, and it would go off, and I have yet to have a student that can hang on to that. Just the pre-tensioner.
Right, yeah.
And then we would go outside and set off airbags, and I know you're supposed to set them off metal side down, airbag side up, but it's more fun to launch them in the air, so, Yeah, we go through the proper procedures, but if you know what you're doing, you can... Okay, well, you know what? We explain the proper procedures, but... Yep. The proper procedure isn't putting a little army man with a parachute on top of the thing. So when it goes up in the air, boom, and then you got a parachuting army man.
Well, okay. So this is actually today we were messing around with this. So we have a lot of our school cars we get from various places, and one of them we have actually already had airbag deployment out of the front two bags and the pretensioners. The curtains hadn't gone off yet, but we took one of the impact sensors, and we were talking about impact sensors and how they're really like modules nowadays. They're sending data packets and information. So we had the scope hooked up, and I was showing them, okay, here's you can actually see the little bits of information, all this. And since it was a school car and already deployed airbags, I was like, let's hit this thing with a hammer and see if we can get that information to change, because it just keeps spitting the same message out on the data line over and over again, as long as you have the key on. And we really went to town on this thing, striking the core support where it was mounted to, but we could not get that message to change. I was actually pretty interested. So I think it's more of an accelerometer thing where it needs to actually have, a deceleration event, or it's just that well engineered. So it recognizes that me hitting the core support with a hammer is not the vehicle collision.
The computer's going, Sean's hitting me with a hammer.
Right. But we were having some fun because all the students are waiting for the curtain bags to go off and everything. But
I know, but isn't that great? Isn't that great when the anticipation, they're like,
yep.
And then if you plan ahead, you got the two jumper wires ready. You're like, okay, boom.
Just a 9-volt in my pocket, ready to go.
Cool.
Yeah. Awesome. Well, thank you for reaching out to me. I'll take the tips and pointers anytime you got them, and I'm sure everybody listening appreciates it.
I just wanted, to add the fuel trim part of that, because I may not have connected a fuel pressure gauge. but you got there. Regardless, you got there, right? It's just the way the fuel trims behave was something that you didn't address, and I wanted to share that with your audience. And if that works and expedites your diagnostic process, then good.
All about that mindset going in. You know what you're looking for and how you're going to approach it, and everybody, I know myself, I'm working on building that every time I go into something. Like, what are the things I'm looking at? What do I expect? Right. And if I see this, I'm headed this direction. If I see that, I'm headed this direction, or I'm doing this test or I'm not doing this test. But you got to have those expectations ahead of time. So information like this really helps get you there.
And we got to talk about blowing up airbags.
Yes, exactly. I'll send you a video next week when we set them off. So
sounds good.
Okay, that's going to do it for today's episode. Big thank you to Scott for taking the time to come on the show today. Definitely appreciate it, and definitely appreciate the advice. I mean, that was basically a fuel trim class there. So I enjoyed it. Hopefully you did as well. I want to say thank you to everyone out there listening and providing feedback. That's always appreciated as well. But with that all out of the way, let's get out there and start fixing the world one car at a time.